Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of laws of exponents. This is standard A.11b in the great state of Texas, and we are using item number 34 of the 2019 released STAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we need to find an equivalent expression, and to this x to the p, really we're just looking what is the value of that exponent right there, okay? So we need to keep a few things in mind, and we've got x to the 22nd power. Let's deal with each of these terms kind of separately, and let's deal with that one first. That is called the power of a power. So what happens when you have an exponent, right, like a to the m, and then you end up taking that whole thing to another exponent, like to the n, okay? Well, what the power of a power, and this is off our mathematics chart or reference materials, whatever you want to call them, you keep the base, right, the base is that big number, and you end up multiplying both of the exponents. So when you have a to the m, and then you take that expression to the n power, it's like a to the m times n. Okay? So let's deal with that x, that second x right there. So that's going to be x to the 7th times 3. Because I'm just going to take both of those exponents, multiply them. So that whole thing turns into x to the 21st power. So if I can substitute this, let me just rewrite it down here now, x to the 22 times x to the 21. Okay, so what do we do with both of those? Well, this is another law of exponent called the product of powers. So we have to be able to recognize this. We have the same base. So this is where you have, for the example, a to the m power times a to the n power. So you need both to have the same base, x and x. If one is a y, one is a z, it's not going to work. Okay? So we've got a to the m times a to the n. What that does is you keep that base, but instead of multiplying like we did with power over power, you add the two exponents. Right? So a times to the a to the m plus n power. So that's going to be x. Then you just end up adding 22 plus 21. So I'm thinking it's x to the 43rd power, okay? And since we're looking for the value of p in x to the p, that p, that's going to be that p right there, that 43. They're just asking what is the exponent. Now, if we want to verify, we actually can with our calculators, right? So if you take, let's just say x equals 2, okay? So 2 to the 43 is going to be this large number, 796,093,022,208. So that's millions, that's 8,796,000,000,000, so on and so forth. Then just do that same thing with that. See if it equals 2 to the 22, and then 2 to the 7th to the 3rd, right? We substitute in 2 for this x to the 43, or 2 to the 43. And you'll find that obviously it does, but you can actually, if you want to make sure you did it right on this one, you can actually substitute in, a value for x. In this case, I would suggest something very small, since you are taking it to the 43rd power. So we need to bubble this in here, since there is no f, g, h, or j to choose from. And it is going to just default to a positive, so we won't have to mess with that over on the left. So we're just bubbling in 43. Nothing new there. Let's bubble in the 4, bubble in the 3, and that is our answer. The value of p is 43.